Okay, I'm going to go over a problem that one of my finance students was having a problem with. And this is a problem, as an end of chapter problem out of this book, M Finance, 4th edition, by Cornet, Adair, Nossinger, published by McGraw-Hill. And here's the ISBN number. Very good book for finance. Keeps things very simple, and it's one I use for my finance class, specifically for corporate finance. So I'm going to go ahead and read the problem here. The future value of multiple annuities. Assume you contribute $200 a month to a retirement plan for 20 years. Then you're able to increase the contribution to $300 a month for another 30 years. Given a 7% interest rate, what is the value of your retirement plan after 50 years? So there's several ways to do this on Excel. I'm going to show you two. I might show you a brute force method, but I'll probably just show you two ways to do this problem. First of all, we're going to go ahead and put in N, R, PV, PMT, and future value. So those are the main, on your financial calculator, those are the main 5 things you do when you're doing a time value of money problem. So we know if there's 20 years to start out with an R of 7%. You want to make sure you type 7%. This is annual, an annual percentage rate. It doesn't tell you that in the problem, but you assume when they don't give you the rate, you just assume it's annual. And the present value, where you're starting out with 0 money. And the payment, since you're paying, you're depositing money, so that's a negative cash flow. So it's a negative, and we want to know in this first 20 years, we don't really know what the future value is yet, but we could figure it out. And then after that, and this is monthly, right? Very important to remember that that's monthly. And then we're going to do another 30 years. And it's the same interest rate. And that's APR also. And this present value, the way I'm going to solve it first, well, whatever we find the future value of this investment, we can turn around and put it here as a present value for the next 30 years. But then we're going to increase the payment. We're going to start saving $300 a month for the next 30 years. So this is a 50-year problem. And then finally, we won't know the future value until we calculate it. So those are the 3 things we really don't know. Well, actually, just 2 things, because this is equal to this, right? This will make sense in a second. So we want to find future value after 50 years, which is, of course, 20 plus 30 is 50 years. So that's what we want to find. So I'm going to do my solution, which might seem a little bit harder, but it's really not that hard. First, we're going to find this future value here. And so the future value after 20 years is equal to the formula future value. And it's asking in bold the rate. The rate is 7%. Now we got to be careful here because this is monthly, right? This is a monthly payment, so it's not $300 a year or $200 a year. It's $200 a month. So I have to take the yearly rate divided by 12. The number of periods is 20 years times 12 months in a year. Our payment is $200, and we could stop right there and not even put a parentheses, but we can go ahead and put the present value as 0, close the parentheses. So after 20 years doing $200 a month at 7% APR, I'll have accumulated $104,185. All right. So then we can calculate the future value again after 50 years. So I can go equals future value. And we're using the same rate. The number of periods, well, remember we got to divide that by 12 because it's per month. Number of periods is, now we're going to do an additional 30 years. And that's going to be times 12. Really, I shouldn't be typing 30, right? I should be clicking on that. And then the payment now is $300 a month. And the present value, well, I have $104,000 in the bank, but I have to put it back. I could take it out right now and I'd have $140,000 and $185.33 in my pocket. But I'm going to turn it around and let it ride, so now I have to put it back in the bank. So it's going to be a negative this, right? Because that's going back in the bank. And then we can close the parentheses. And so that would be my answer. Okay. And let me put this formula down below here. All right. So this is my answer. So I'd have $1.2 million after that many years. All right. So I'm going to do an alternate solution. This is actually the way the book suggests you solve it. And it's actually a very elegant way to do it. So what I could say, well, we actually had, instead of having $200 a month for 20 years and then $300 a month for 30 years, I could say for 50 years I have $200 a month. So I can calculate the future value of $200 for 50 years. Okay, so that would be equal to future value. The rate again is 7% divided by 12. Number of periods is going to be 12 times, well, 50 years is going to be this plus this, right? And then the payment is going to be $200. And there's no present value. I'm just going to hit enter at this point because present value is 0. Since this is an Excel function, I don't need to close the parentheses because Excel is going to know. Well, maybe not. I guess because I have this parentheses in here, I confuse it a little bit. Normally, you don't have to do that ending parentheses, but in this case, I actually did it. Excel did it for me. It said, "Hey, where's your ending parentheses?" and I put that as a default. Okay, so now we want a future value of. So now we want picture this in your head. We want $200 going through for 50 years. Well, we're still missing the $100 for 30 years. So we're going to say $100 for 30 years because we still need that. We put this formula. And then $100 for 30 years is going to be equal to future value. The rate is still 7%. Don't forget to divide by 12. Number of periods now is going to be 30 times 12 for months. The payment is going to be equal to this minus this now, right? Because it's $100. And then we don't have to worry about the present value. So that $100 additional dollars for 30 years. So now I have all the cash flows. So now all I have to do is just add it together. And we get the same answer. Okay. Now, another way we could do it using the brute force method. And let me just go ahead and do it. So I'm going to say the brute force. And sometimes the brute force method, like maybe you have something more complicated going on than just $200 and $300. You want to, have something go over. You want maybe over your life, you want to increase it a certain percent. And you do something like this. So we say period. And then we go cash flow. And we go to the future value of the cash flow. Okay. And we're going to start out with period 1. And 50 years, we can go here. We know equals 20 times 12. So it's 240 months for the first 20 years. And then the 30 years is going to be 360 months. I'm not going to do the math. So we're going to have a total of 600 months. So I'm going to go 1 and then 2. and then go all the way down to 600 periods. That's why this is brute force. We're doing a lot of periods. And we know we have $200. And the 200, I'm going to copy that all the way down for 240 months. Now you see why this is really brute force. And then we're going to have, here we're going to have, I should you really go equals the $300. I'll just type it. We don't have to go equal. I'll just type it. I'll go $300. And I'm just going to double click to send that down. And what I really could do, let me do this a different way. Instead of finding the future value of these, I'm just going to find the net present value of all this. Okay. Now you know what? I'm not going to do that. Let's do it the way we're. There's so many ways to do this. So we want the future value of each cash flow. So we know the future value. I'm going to go equals future value. And the rate is going to be this. I'm going to F4 this because I always want it to point to that, right? So after I do that, I'm going to hit F4. We try it again. Is equal to this. F4. And the F4 puts dollar signs. It makes that an absolute reference. Divide by 12. And the number of periods is going to be, well, how many periods it is out the future. Well, this is the end of period 1, so it's going to be equal to all the way down to the end. We're going 600 periods. And I always want to have that first, so I'm going to hit F4 again. Hopefully this makes sense to you. And then I'm going to subtract 1. So it's actually 599 periods. I want that. I want to find the future value of this, right? And the payment is going to be, we want to make it negative. So I'll say a negative this. Oh, I forgot to do the comma to get into the payment. And the present value, I don't care about the present value. Actually, you know what I'm going to call it? Instead of calling that a payment, sorry, this might be confusing. I'm going to call it a present value. Because in this case, we're going to consider each one of these a present value. So, so this is a present value, and I want that to go 599 periods. I want to find out the future value of that one cash flow is 599 periods in the future. So the next one is going to be 600 minus 2, so it's going to go 598 periods. And then it's always going to point to the 7%. And you can click this, and then we can just copy this down. It's going to do every one. Let me put the formula in here. And so now all you have to do is go down to the bottom, and if we did it right, let's see if this worked. I'm going to sum it, and I have the same answer, 1,211,611.28, which is the same thing we got here. Okay. Now I'm going to show you one more way to do it. I know this, if you're already tired, you know, I'm sorry. I'm just going to show you probably another way you could use, I'm going to say NPV to future value solution. So the first thing I want to do is I want to find the NPV. Of all these cash flows. So I'm going to go equal NPV, that stands for net present value, and the rate is 7%, and it wants all the cash flows. So all these cash flows are, you always want to start at period 1 with NPV, okay? So NPV always assumes that it's period 1. So we're in the right spot. So I'm going to hit this, I'm going to hold shift and down to get all the cash flows. And then I'm just going to hit enter. Now I want to take this and divide it by 12. So that's the net present value of those cash flows. So I want to find the future value of those. So I'm going to go equals future value. And the rate, again, is going to be 7% divided by 12. And it's going to be 600 months. We're just going to go ahead and go click on the 600. And there's no payment. And we're going to consider this the present value. So I'm going to go negative this. Let me just check. Rate. Number of periods is 600. No payment. Present value is a negative that. And I get the same answer. Okay. So, I don't know. You figure out which one you like. So there's a lot of ways to do this problem. I'm just showing you a few. Like I say, the book solution right here is a very elegant way to do it. So hopefully that helped. Hopefully that wasn't too much. You know, I showed you probably more ways than you want to know how to solve this problem. But if you didn't understand something, and I know I didn't explain some of the things as good as I would have liked. But if you didn't understand, just kind of rewind and look at it again, or look at the equation, see if you can understand what I did. So if you like my video and you want to subscribe, my picture is going to come up here. Click on that to subscribe to my channel. If you liked it, click like, and hope that helped. Thanks for watching.